Concept 6b, transformations of quadratic functions. In this section, we're going to talk about reflections. So a reflection in the x-axis is a flip of a graph over the x-axis or a horizontal line of reflection. We're also going to talk about stretches and shrinks, vertical stretch and shrink. These are all type of graph transformations. We started transformations in section A. So a vertical stretch is when the graph stretches away from the x-axis and the graph narrows. A vertical shrink is when the graph stretches towards the x-axis or the parabola widens or flattens. So we're going to start by graphing the parent function, and the transformed function f of x equals to 2x squared. So we've got a value a now, and a is 2. So graphing the parent function, first of all, let's draw an xy axis, label our scale. And then values for our parent function, the center is at 0, 0, or the vertex, negative 1, 1, negative 2, 4. Because it's just the equation y equals x squared, 1, 1, and 2, 4. So we'll have this in front of us as we graph our next function, which is f of x, or y equals 2x squared. And now you can see that my slide has switched, but we'll just go ahead and graph this 2x squared like we were planning on. So for our xy values, I can tell, thinking of vertex form, there's no number added or subtracted to my x value, so my h is 0. There's no number added or subtracted at the end, so my k is also 0. So I'm going to plug in negative 1, negative 2, positive 1, positive 2. If I square negative 1, I get 1, times 2 is 2. Negative 2 squared is 4, times 2 is 8. 1 squared is 1, times 2 is 2, and then I will get 8. I'm going to graph this in red. Negative 7, 8. There. Now you can see the graph of our transformed equation, the y equals 2x squared, the red graph, is skinnier, it's narrower than the parent function. And so this is what we call a vertical stretch. I can know that by looking at my equation because my a value is 2. And if a is greater than 1, then I will have a vertical stretch. Now let's graph the transform function f of x equals negative 1/2 times x squared. Our a value is now negative 1/2. So we'll see what happens when our a value is negative and also when it's a fractional amount. I have the parent function graphed already so we can compare it. And this is, I know that my vertex is going to be at 0, 0 because my h and k, so I'll see what's happening at negative 1, negative 2, and 1, 2. So if I square negative 1, I get positive 1 times negative 1/2 is negative, and I'm going to write that as 0.5. So negative 0.5. Negative 2 squared is 4, and then half of 4 is 2, and we'll make that negative. Now, if you've noticed, parabolas are symmetrical, so if I have points evenly on either side of the vertex, my y values will be the same. So now let's graph this, and I'm going to graph it in red so you can see the difference. So negative 2, negative 2. negative 1, negative 0.5, 0, 0, 1, 0.5, and then 2, positive 2. Now take a look at that graph. Notice how the graph is wider than the parent function. That's because the a value is less than 1. And when I'm talking about the a value, I'm going to ignore the negative for a moment. Now also notice that this graph has been reflected and then widened. And so it's reflected across the x-axis. So the negative gives us an x-axis reflection. All the y values that were positive and up in these upper quadrants here are now negative and then widened. So an x-axis reflection, and that's because of our a value being negative. Now here are just some definitions to get down. So a vertical stretch, you can write these notes when the absolute value of a, so we're ignoring if it's a negative, the value of a is greater than 1, then it's a vertical stretch and the graph will narrow. When the value or absolute value of a is less than 1, it's a vertical shrink and the graph widens or flattens. If the output is multiplied, so everything that y equals is multiplied by a and the value of a is negative or opposite of the original function, then it's an x-axis reflection. So we saw negative 1/2 was a graph that was wider than the parent function because that a value is less than 1, and then was an x-axis reflection because in the parent function that original a value is positive. Now one final note that you can put in your notes. If the input, so the x is negative or opposite, then it's what we call a y-axis reflection. We're not going to graph these, but I just want for you to put this note in your notes. Because a y-axis reflection is interesting. The parabola is its own reflection in the y-axis. Here's an example. So if you have the function, just the parent function, f of x equals x squared, and then you put that negative 1 inside the parentheses, what will happen is that, so you'll have a parabola, and let's try that again. So a parabola, and yes, your x values will be that were positive, were negative, are now negative. So they will be switching over. But essentially that thing is just going to flip onto itself. And so it looks like the original f of x equals x squared. And it will actually simplify to that as well. Because negative 1 times negative 1 is a positive 1. Now pause the video and do the independent practice problems and then come back and check those. So here's the answer to independent practice number 1. So you're graphing negative 2x squared. Notice that this graph is skinnier than the parent function and that it opens down, and that's because our a value, so our value, absolute value of a is greater than 1, so it is a vertical stretch, it's narrower. And then a is negative, and it's an x-axis reflection. On this problem, we're writing the equation of the graph that we see, and we're going to identify the vertex. So we can just assume that this graph is going by ones. So our vertex, we'll identify that, is at 1, negative 3. Now we'll check and see in the normal parent quadratic, y equals x squared. If we put in 1 and we square it, then we get 1. And here we'll move over 1 and up 1. And then if in a parent quadratic, if we put in 2 for x and square it, then we will get 4. So from our vertex, if we go over 2, then we go up 1, 2, 3, 4. So that is not skinnier or wider than the parent function. So I know that my a value is just going to be the same as the parent, and it's 1. So I can use that general form of a quadratic function in vertex form. So y equals a times x minus h quantity squared plus k. So y equals 1 times x minus 1 quantity squared minus 3. And that's the equation that creates the graph that you see. On number 3, we're going to describe the transformation of the graph from the parent function, so which is f of x, or y equals x squared. So notice our a value is negative 4. So since 4 is greater than 1, I have a vertical stretch. Since a is negative, so that's a negative, I have an x-axis reflection. And then my vertex is at negative 1, because I look in terms of subtraction, negative 1's being subtracted, and then negative 5. So that is a translation that is to the right 1 and down 5. Now my second function, my a value is 1/2. Since a is less than 1, that means I have a vertical shrink. My h value is positive 1. My k value is 0. So there's my vertex, and this shows me that I have a translation that's horizontal, and it is 1 to the right.